Hello everyone, welcome to my video. In this video, we will talk about absolute motion and the relative velocity for rigid bodies. We looked at this table in the previous video. When analyzing absolute motion for a rigid body, the key is to being consistent. Choosing the correct positive direction is one. There are not really anything new here, but questions we encounter will become more complicated as they are most of the time involve linear and angular variables at the same time. On the next slide, I will demonstrate the basic technique of analyzing problems related to rolling wheel as an example. Here we have a wheel with a center O, radius r, traveling with a velocity VO. You should notice here the traveling velocity is not randomly set to be VO. I didn't choose V1 or V0. I said VO. It is because the traveling velocity of the wheel is essentially the traveling velocity of the center point O. We will also identify 2 points, point A and point B, on the wheel as shown. After a short period of time, the wheel will travel by distance s. This distance can be measured by O to O prime. We'll also assume that there's no slip of the wheel, so therefore the s is also equal to the arc from A to B. Looking at the segment OA here, compared to its original state, it tilted by angle theta while the wheel traveled for distance s. Right? When you're traveling, your A should be tilted. Therefore, we can calculate the arc AB by using radius times angle, which is also equal to S. We will take the derivative of this equation. The first derivative gives us the velocity, s naught, and the second derivative gives us the acceleration. We have obtained the 3 basic equations here, S, VO, and AO. Let me get rid of the wheel and only keep those key points so we can see it clearly here. For point A travels to point A prime, horizontally, A traveled distance by x can be calculated by s minus r sine theta. And vertically, A traveled by distance y can be calculated by y equals to r minus r cosine theta. Therefore, horizontally, looking at the x equation, we can take the derivative to get x dot and x dot dot, which is acceleration, and recall that VO equals to r omega, and theta dot, the changing rate of theta dot is omega, as we derived on page 5 if you need to go back to look at it. Vertically, we'll do the same thing. Right? When A travels the distance y from A to A prime, and we will end up with a bunch of equations as well. I'll put them together on next slide. Now, we have the 2 ultimate equations here, one for x and one for y together here. The angle theta is a measure of the angular displacement, and we can set it to 0 to represent the instant at the beginning when the wheel was at rest and when the point A was still in contact with surface before rotating. Right? It's right here. By doing so, we get these 2 equations simplified to x dot dot equal to 0 and y dot dot equals to r omega squared. As a result, we can come up with a conclusion that the contact point of the wheel has acceleration only depending on the radius r and angular velocity omega. The acceleration is directed towards the wheel center, which is the n direction, the normal direction. These 3 basic equations of relationship that we developed at the beginning will hold on any rolling wheel related problems. And this concludes our investigation on the absolute motion.